Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
That problem of how to increase the speed of the modern supercomputer and increase that speed by a factor of 1 million was the grand challenge problem of mathematical physics that was posed back in February 1, 1922, and that I solved on July 4, 1989. I discovered how to solve in only one day and across that new internet that is a parallel supercomputer, and how to solve a grand challenge problem that would have taken millennia upon millennia of time to solution on one computer. For 67 years, onward of February 1, 1922, parallel processing was abandoned by supercomputer experts. Supercomputer textbooks dismissed parallel processing as science fiction. Parallel supercomputing was ridiculed as a huge waste of everybody's time. Because my massively parallel supercomputer was an unconventional technology and a new internet, I used an unorthodox technique to send and receive my 65,536 computational physics codes that I had to email to my as many processors of my new internet. Deep inside the parallel supercomputer, the email is the recurring decimal across each pair of bidirectional email wires that connects nearest neighboring processors that shared nothing. I had 65,536 unique email addresses for as many processors. Each processor operated its own operating system. Each email address was 16 bits long, or a unique string of 16 zeros and ones. My email addresses within that new internet were unorthodox because they had no @signs or .com suffixes. Their @signs and suffixes were unnecessary because I knew where my 65,536 processors that outlined and defined my new internet were at. My discovery of practical parallel supercomputing began with some back-of-the-envelope calculations and a few proof of principle lectures in which I presented my realizations that 1 million processors could in principle be harnessed to solve the toughest problems arising in mathematics, physics, and computer science. My proof of concept was small and was not complete. I gave my proof of principle lectures back in the early 1980s. At that time, parallel processing across 16 times 2 raised to power 16, or 1 binary million bidirectional email wires, was the frontier and the unknown territory and the science fiction of the world of the supercomputer. 67 years earlier, a meteorologist presented as science fiction the story of 64,000 human computers working together to solve a grand challenge problem such as forecasting the weather around the entire planet Earth. That science fiction story was published back on February 1, 1922. But unlike the science fiction writer, I, as a non-fiction, research massively parallel supercomputer scientist, had a very limited number of words that I can use to describe how I emailed my initial boundary value problems of mathematical physics and how I sent them across a never-before-seen internet. That is a new global network of 64 binary thousand processors. As a supercomputer scientist, I'm different from the science fiction writer because the starting point of the science fiction writer is a blank page plus the unlimited fictional stories that she can conjecture and that she can use to populate her blank pages. But as the first parallel supercomputer scientist that started his quest for the solution of grand challenge problems and started on a conventional supercomputer and started on June 20, 1974 in Corvallis, Oregon, United States, and continued almost daily for 15 years and continued to the capital of supercomputing, namely Los Alamos, New Mexico, United States. And as that first modern supercomputer scientist, I couldn't make up fictional stories that could not be reconfirmed by each and every subsequent parallel supercomputer scientist. As the non-fiction supercomputer scientist that I was, I could not write a word about practical parallel supercomputing and do so until I, first and foremost, divided my grand challenge problem into smaller, less challenging problems and then synchronously emailed them across my 1 binary million email wires that interconnected my processors and then simultaneously solved them with the one-to-one problem-to-processor correspondence that I maintained between my 64 binary thousand smaller mathematical physics problems and my as many commodity off-the-shelf processors that shared nothing between each other. My first discovery of practical parallel supercomputing that occurred on the 4th of July 1989 was rejected as a quote-unquote terrible mistake. Back in 1989 and earlier, practical parallel supercomputing was mocked, ridiculed, and rejected as a pitiful theory that lacked an experimental confirmation. My supercomputing quest was to experimentally confirm massively parallel supercomputing and reconfirm it to a speed limit that was never before attained, namely across a never before seen internet that was my new global network of 65,536 tightly coupled commodity off-the-shelf processors. For that invention of a new supercomputer, I used the toughest problems in mathematical physics as my computational test bed.
Insightful and brilliant lecture.